So in continuation with our nameplate details of substation equipment series, in today's video we are going to discuss about the parameters which are mentioned on a nameplate of high voltage disconnector. And also we are going to discuss about the different types of disconnector which are currently used in power system. So to get all these details you need to watch the video. So before moving on in this video, if you would like to see the previous videos of this series, you can watch that. You will get link for those videos down in the description. So moving on in this video, firstly you will find the name of the manufacturer. Then here you will see all the details are mentioned about the customer, who is the client, who is end customer, what is the project name, and etc. etc. So these are the project related things. So moving on, the rated voltage. So here you can see it is mentioned as 420 kV, which indicates this disconnector is designed for 420 kV of rated voltage. Moving on is STC, that is short time current. So here you can see 50 kilo ampere for 1 second, meaning that this disconnector can withstand 50 kilo ampere of short circuit current for 1 second, and it is tested for the same. So if you see, there is also one value mentioned which is 125. So this is the making current, or it is also called as a dynamic current. So let's see what is this. So in case if your breaker closes during an existing fault, the short circuit current may rise up to a certain value, and we call that value as making current. And it is generally, as per IEC, 2.5 times the rated short circuit current. So here in our case it is 50k. So if you multiply 50k with 2.5, you will get 125 kilo ampere peak. It is in peak because it remains in the system for a very short time. So moving on, you will see power frequency voltage. With this we will also understand what is impulse voltage. Now these are the basic insulation values which every equipment should have. So as this is a 420 kV, the manufacturer should have mentioned the switching impulse as well, but unfortunately it is not mentioned here. So we'll see what is power frequency voltage. Now power frequency voltage can be generated due to these reasons: phase to earth faults, load rejection, ferro resonance, and Ferranti effect. These are the some causes of power frequency withstand voltage. Now this disconnector is tested for the same and can withstand a certain value of power frequency voltage. Now this lightning impulse is generally generated due to lightning strokes. But if you see carefully, you will see in the impulse section it is mentioned as 1425 in bracket plus 240. Now we will see what is this. So 1425 is the impulse voltage which is applied to earth. And if you add 1425 plus 240, you will get a value of 1665 kilovolt peak. So this is the value which is applied across the isolating distance. So from one side they will give one shot of 1425 kV peak, and from another side they will give one shot of 240 kV peak. So moving on, next is operating device. So here you can see it is mentioned as MOM, which indicates motor operated mechanism. Now disconnectors generally comes in two different operating mechanism. One is motor operated and another is manual operated. So in case of manual, you have to go there and manually spin the handle to open or close the disconnector. In case of motor operated, you just have to push the button and the motor will do the rest of the work. So below 420 kV you will generally find both the variants, that is manual operated as well as motor operated. But in case of 400 kV, generally customers prefer to buy a motor operated device. So moving on, the rated AC voltage. So this is the AC voltage on which the motor is operated. So it is 3-phase 415 volt AC. Moving on, the year. So this indicates the year in which this particular disconnector is manufactured. Moving on, the type of disconnector. So it is mentioned here as DBR, which indicates double break type disconnector. Now let's see what are the different types of disconnectors which are currently used in power system. So firstly, double break type. So as you can see, this type of disconnector opens from both the ends, that is they break from both the sides, and that is why it is called as a double break disconnector. This type of disconnector is generally used between 11 kV to 420 kV. So next type is horizontal center break. So as you can see, it breaks from the center, or it is also called as single break, because as you see there is only one break. So it is also called as a single break disconnector, and this is also used between 11 kV to 420 kV. So next is Pantograph type. So Pantograph type disconnectors are generally used for 245 kV and for 400 kV. So next is knee type disconnector. So knee type disconnectors are only used for 800 kV. It looks like when you bend your knee, it will look like the same. So it also looks like one big robotic arm. This is only used for 800 kV. Here is the comparison slide. You can take screenshot of this in case of your future use. So this will show the different types of disconnectors which are currently used in power system. By the way, if you would like to know what is the difference between circuit breaker and disconnector, you can watch my video on that. You will get link for that video down in the description. So moving on to the nameplate. So next thing is a rated current. So here you can see this particular disconnector is designed for a rated current of 3150 ampere or 2000 ampere. So impulse we already saw. Next is the rated frequency. So this indicates the rated frequency for which this disconnector is designed. So as it is designed for India, it is 50 Hz. Next is a DC voltage. Now DC voltage is required inside the control box which controls the disconnectors, and this is the control voltage. So it is 220 volt. It can be 110 volt as well. So next is weight of MOM. So this indicates the weight of your mechanism box. So it is mentioned there, and also the weight of total disconnectors. Now one thing the manufacturer is missed here, the IEC standard. So it is mandatory to mention the standard as per the disconnector is manufactured. So it is not mentioned here, but for your information you can note it down. It is IEC 62271-102. So this is the IEC standards for air insulated disconnecting switches. So that's all for this video, guys. I hope you found it helpful. If you like the video, you know what to do. So that's all for this video, guys. I'll see you in my next one. But till then, keep watching, keep learning.